If you stand at the bottom of the Mariana Trench, 10,984 meters below the surface of the Pacific, the weight of water pressing down on every square inch of you equals roughly 50 fully loaded jumbo jets, and the fish swimming past your feet have no idea. Any of that is unusual. You'd think a place this hostile would be dead. No light or no warmth. Pressure that crushes a sealed steel cylinder like a soda can. But what's actually down there is the opposite of empty. Soft, pale animals are gliding around like the conditions are perfectly normal. They're not visiting or neither surviving. They live there full time and they couldn't leave if they tried. So here's the question. How does anything actually function under 16,000 pounds of pressure per square inch? Why do these creatures look the way they look? And why does life look completely different 10 kilometers up, even though the same animal, evolutionarily speaking, started in both places? To answer that, we're going to do something a little strange. We're going to start at the bottom and watch life slowly turn back into something you'd recognize. The bottom of the Challenger Deep is roughly 2 degrees Celsius, completely black and quieter than any place you have ever been. The terrain isn't dramatic. No towering cliffs, no glowing coral, just fine sediment, the consistency of flour that puffs up into a cloud the second anything touches it. The first thing you notice is the snailfish. About a foot long, pale pink, almost translucent. It moves slowly, deliberately, like the water itself is thicker down here. And in a sense, it is. The way the snailfish survives is genuinely remarkable because it does not resist the pressure. It can't. No animal can. Instead, its body is built so the pressure simply passes through it. It has no swim bladder, no air-filled space anywhere in its body. Its skeleton is mostly cartilage, soft and flexible. Its skull is partially open at the top, so its brain doesn't get crushed inside its own head. Its flesh is so gelatinous that if you brought one to the surface, it would melt into a puddle within minutes. There's also a chemical trick. Inside the snailfish's cells are molecules called piezolites, tiny compounds that act like internal scaffolding, keeping proteins and cell membranes from collapsing under force. Without them, every cell in the fish would liquefy. With them, the fish doesn't even notice the pressure. From its perspective, this is just water. Around it are the amphipods, shrimp-like crustaceans, a few centimeters long, that scavenge whatever drifts down. Some of them have built aluminum-based armor into their exoskeletons by pulling minerals straight from the sea floor, basically growing a metal coating because regular shells aren't enough this deep. And here's the part that's genuinely strange. These animals can't go anywhere else. If a snailfish swam upward, even 3 or 4 kilometers, its body would decompress and disintegrate before it ever saw the abyssal plane. It is built for this and only this. The trench is its entire universe. So what happens the second you start climbing out? 6 kilometers up, the seafloor flattens out into an enormous, near-empty expanse. This is the abyssal plain. It covers roughly half of Earth's total surface, more than every continent combined, and most of it has never been seen by a human eye. The pressure here is around 600 atmospheres, still enough to instantly kill you, but notably less than the trench, and that small relief changes the rules. Animals here are larger, they're more numerous, they're recognizably built like animals. You start to see tripod fish which stand on long stilted fins on the seafloor and wait completely motionless for food to drift past. You see rat-tail fish with their thin tapering bodies gliding low over the sediment. You see giant isopods, pillbug relatives the size of small dogs, slowly walking across the bottom like armored tanks. This is where deep-sea gigantism really starts to take over. Cold water, low metabolism, scarce food, almost no predators. Animals grow slowly, but they don't stop growing. A giant isopod can live for decades and reach 50 centimeters long, about the length of a forearm. The food source is a slow, constant drizzle of organic debris from above. Scientists call it marine snow. Fragments of dead plankton, fish waste, mucus, and occasionally something larger. Every few decades, a whale dies near the surface and its body sinks here. When that happens, an entire ecosystem materializes on top of it, feeding for years on the carcass and eventually the bones. But the abyssal plain is still mostly dark and mostly cold. To find anything resembling color or motion, you have to keep climbing. This is where the ocean stops being a still photograph and starts being a movie. The pressure has dropped to around 100 to 400 atmospheres. The temperature is still cold, around 4 degrees Celsius. There is still zero sunlight. But for the first time, you start seeing light that wasn't put there by humans. About 80% of animals in this zone produce their own light. Lanternfish carry small glowing organs along their bellies. They tune the brightness to match what little ambient light filters from above, so predators looking up from below see nothing but blank water. Anglerfish dangle a glowing lure in front of their teeth and wait for something curious to investigate. The vampire squid, despite the name, is a soft, slow drifter that flips itself inside out when threatened, exposing a glowing, spiked underside that makes it look much larger than it is. Then there's the gulper eel, basically a swimming mouth attached to a long whip of a tail. Its jaws can open 3 to 4 times the width of its own body, allowing it to swallow prey nearly as big as itself. In a zone where meals are rare, you take whatever passes by, even if it shouldn't fit. Notice what's happening as you climb. The animals are getting more decorated, more mobile, more predatory. The deeper you go, the simpler and more passive life becomes. Soft bodies, slow movements, conservative metabolisms. The shallower you go, the more extravagant it gets. Bioluminescence, ambush hunting, expandable jaws, complex eyes. That's not random. Light, food, and pressure all loosen their grip the higher you go, and evolution immediately spends that surplus on showmanship. So what happens when sunlight finally returns? You start to see blue, faint but real. The first traces of sunlight have been filtering through for hundreds of meters, with the warmer wavelengths, red, orange, yellow, absorbed long ago. Only the shorter blue wavelengths make it this deep. This is the twilight zone, and it's the most populated layer of the ocean by sheer biomass. Most of that biomass is small: lanternfish, hatchetfish, bristlemouths, krill, but every night, an enormous fraction of it migrates up toward the surface to feed, and every dawn, it sinks back down. This is the largest daily animal migration on the planet, and it happens entirely out of human sight. Eyes here are huge, often pointed straight up, designed to spot the silhouette of anything moving against the dim blue glow above. Bodies are silver and reflective, or transparent like glass. Stealth is the whole game. You're either invisible or you're food. This is also where animals start to look familiar again. Squid that resemble the ones served at restaurants. Fish that look like fish. Sharks like the megamouth and the goblin shark cruise through this layer, but even they look more like normal animals than like the alien forms you saw 2 zones ago. And then, suddenly, everything changes. In the last 200 meters of your climb, the water turns from blue-black to bright blue to clear. Sunlight comes back hard. Pressure drops to around 1 atmosphere, what your body has been built for since the day you were born. Phytoplankton blooms catch the sun and turn it into food, supplying the entire base of the marine food web. Krill swarm by the trillions. Sardines flash in coordinated schools. Tuna, marlin, Dolphins, sharks, and seabirds tear through the upper 100 meters in a constant high-energy chaos. This is the part of the ocean every human being thinks of when they hear the word ocean. Warm, loud, crowded, familiar, and it represents less than 5% of the total water column. Now look back down. You just climbed roughly 11 kilometers. From a place where life is gelatinous, blind, and slow, up through layers of glowing predators and silver migrators, into a sunlit zone full of motion and color. From the human perspective, it looks like life got better the further up you went. Less pressure, more food, more light, more activity. But the snailfish at the bottom doesn't see it that way. To the snailfish, the surface is the hostile place. The surface would kill it in seconds. Its world, pitch black, near freezing, 16,000 pounds per square inch, is the only world that works. Climb out of it and you don't survive. Stay and you're fine. Most of the ocean isn't the bright, busy strip we've spent our entire lives on the edge of. Most of the ocean is the dark, slow, heavy world underneath. By volume, by area, by the sheer amount of life that lives there full time, the trench is the rule and the surface is the exception. We just happen to live on the exception, and we built our entire idea of normal around it. The snailfish isn't the strange one. We are. Thank you for watching this far. I read every comment, so if there's a specific zone or creature you want broken down next, drop it down below.